Okay. So, well, first of all, thank you so much for giving me the chance to meet with you guys through the internet. Kenya is one of the dream countries I would love to visit, so I'll make it there in person one day. So, I just want to understand our interaction a little better. Can you show hands if you are a PhD student? Okay. A few of you. Show hand if you are a master student. And show hand if you're undergrad. Wow. And show hand if you're already working industry or awesome. Okay, great. And okay, so your first question is how did ImageNet came about? And I'll try to tell you a story, and I want to particularly emphasize that there's a couple of surprise elements of ImageNet that might not be widely known to many of the audience, and it underscores an important point I want to make, is that how important it is to have an interdisciplinary mindset when we do research, and the interconnection between artificial intelligence, computer vision, and human cognition. So, as you know, my field of research is computer vision, and computer vision as a research field is intimately related to even the early days of AI. Very soon after AI was established as a field, we've got researchers in MIT mostly and Stanford in the 60s and even 50s looking at how we can make sense of the pixel world. And Plato, thousands of years ago, actually had a story of how hard it is to do vision. And the story is the following. He said, you imagine a prisoner that is put on a chair and his hands tied, and he's only allowed to look in front of him. And in front of him was a wall in a cave. And behind him are people playing a story on a stage. And the light comes from the stage behind the prisoner, shines onto the wall. So what the prisoner sees, because he's not allowed to move his head, what the prisoner sees is the projection, the 2D shadowed projection of whatever is going on behind his back onto that cave wall. And the task of the prisoner is to understand what is going on in his back in terms of the play and the story. And Plato used this to illustrate that is human vision. We live in a 3D world. If you add time, of course, it's 4D. But the projection of the natural visual world is 2D on our retina. And it's a fundamentally difficult issue to resolve. And so through evolution, our brain took millions and millions of years to formulate a visual system that has resolved that issue. So we live in this world, we understand what's going on in those 3D worlds through these 2D images, and we make sense. So why did I say this? Vision is hard. And the goal of vision is not just to see the colors of the pixels, as you know. The goal of vision is to make sense of the 3D world that's extremely rich and understand the contents. So fast forward from Plato to the dawn of AI, computer vision was born as a field, but the history of computer vision is not 100% coming out of AI. The early branches of computer vision, a lot of that come from image processing in electrical engineering. And some of you might be even getting an electrical engineering degree as you study computer vision. Personally, my PhD was in electrical engineering. So for many decades, especially in 70s, 80s, 90s, early 90s, much of computer vision was working on the geometrical aspect of vision, because there is this consensus that a lot of vision is about reconstructing that 3D model of the world. And it's a really important problem. Today, thanks to deep learning, there's a rebirth of interest in reconstruction. And I'm not going to get into the details of reconstruction. It's highly geometrical, it's shape related, and all this. But vision is not just about reconstruction. In fact, humans suck at reconstruction. We don't have very good geometrical models of the world. So what does human visual system do? So what happened is that an important development in cognitive science, in vision, really changed the course of computer vision research in the 90s, is when scientists in the psychology labs started to notice or to do experiments to prove one of the most important visual tasks in human vision is for humans to recognize objects. Whether it's a cat in front of us, a chair, a leaf, a species of dog, a car. Of course, evolutionarily, it makes sense. We have to pick different fruits to eat. We have to avoid animals to be eaten. We have to understand trees to build our houses. We have to navigate the forest, the rivers. So object recognition became such a critical part of human vision that some of the most exciting work I remember as a graduate student in the 90s is neuroscientists have found through fMRI research that brains have areas that are devoted to object recognition, especially important objects like faces or body parts and so on. So why am I saying this? As a precursor to ImageNet, around 90s, so I became a PhD student in the year of 2000, but in a few years leading up to that, a group of computer vision scientists, people like David Lowe, Jitendra Malik, Pietro Perona, who became my advisor, started to tell the vision community, hey, let's not just do 3D reconstruction. We have a critical problem to solve, which is object recognition. And through their work, within a few years, object recognition, like today, you're like, oh, of course. But it was really through the efforts in the late 90s, the first generation PhD students like me started working on this very early important problem of object recognition. So we started working on object recognition, and we started to combine methods in machine learning community, such as support vector machines and Bayes nets, boosting. And as students of machine learning, you know that one of the most important elements of modern machine learning is that we use training data to teach computer how to learn. We don't write all the rules and all that, right? So as a graduate student, I remember that gathering training data for computer vision object recognition task was kind of a new challenge in the field, because people just didn't deal with training data much at all. And even the machine learning community, you guys are too young, but machine learning community at that time was using a really tiny data set called UC Irvine data set with a few document data. It's just, compared to today's standard, it was just a joke. So no one really has much data, and the computer vision community didn't have much data. Interestingly, very early 2000 is also the revolution of digital cameras and the early internet. I remember my PhD advisor, Pietro Peronna, bought like a $6,000 digital camera. It was so expensive, there was no smartphone. And he was so enamored by that digital camera, he'll take it everywhere, for lunch, for group meeting, for whatever, and he'll take pictures. And we started collecting training images at Caltech ourselves for our first projects. So one of the first projects that was very famous, and it wasn't part of my project, the first author was a former student called Rob Fergus, who is a leader in machine learning these days at Facebook, was also a fellow graduate student. And he and Pietro Peronna and Andrew Sisselman, Professor Andrew Sisselman in Oxford, had a collaboration using 4 categories of objects: faces, leopards, airplanes, and cars. And I remember for both faces and cars, it was pictures taken at Caltech. We used that digital camera and took hundreds of pictures, and it was a massive, expensive effort. And for leopards and airplanes, I think they either bought it or somehow got some license from a photo stock collection, but we're talking about hundreds of pictures. It's not a lot. And that's 4 categories. And that become, as far as I can remember, one of the first papers in computer vision object recognition that showed us using a data set to train, at that point, a mixture of Gaussian model, we can do object recognition. But the process of collecting data was so painful. It was so painful that after that project, Pietro, my advisor, said to me, because I was entering the field of computer vision, he said, Fei Fei, look, it's too painful to get training data for computers. And humans don't need hundreds of pictures, right? Kids look at a few pictures of tigers, they go to the zoo and they say, oh, there's a tiger. Why don't we just do one-shot learning? So, long story short, I struggled for about a year, and my very first computer vision published in CVPR was called One-Shot Learning of Object Categories, precisely because we believe first, humans could do one-shot learning, but second, it's just too painful and impractical to do one-shot learning, to do many, using many examples. So quite an opposite approach to what ImageNet was doing. So anyway, so I entered the field, was focusing on object recognition, and but as good as one-shot learning paper was, it was unsatisfying because, first of all, we actually cheated a little bit. To do one-shot learning for cars, we pre-trained the model with hundreds of pictures of leopards, airplanes, and faces, because we had that 4 categories. So we cheated. To do one-shot learning of one category, we used hundreds of pictures from the 3 other categories. So it is one-shot learning for the new category, but it's not one-shot learning for the system. The system was learning the world of pictures. So it was unsatisfying. And on top of that, I started to read more cognitive neuroscience psychology papers and realized that children learn a lot by experiencing. There's a lot of just looking and touching and exposing to the world that really is not reflected in the way we do machine learning and computer vision at that time. But I didn't take that thought too far because I was busy, generating CVPR papers and trying to graduate. And so I graduated in 2005, and I became an assistant professor. And at that time, my first job was in University of Illinois. I don't know if you know America's geography well enough, but University of Illinois is right in the middle of America. It's right below Chicago, so it's center of America. And I was a first year assistant professor, and a very interesting opportunity came. I went to college as an undergrad in Princeton, and Princeton called me and said, we have a computer vision opening for computer vision professor. Can you please come and check out? We want to see if you're interested, because it's my, what we call alma mater in like my home school. So I was very interested, so I went to Princeton. And that was 2006, I went for an interview. And during that trip, I went to the psychology department. And it was in the middle of 2006. I was still working with very small data sets of object categories. I met a linguist. Her name is Christiane Feldbaum. She has been a linguist, a computational linguist for many years, and the most important work she did was with her senior collaborator called George Miller. Have you guys heard of this name? Raise your hand if you know who George Miller is. No, huh? George Miller was a linguist. He's very senior. He was in his 80s or very senior. And he, in the 80s, started to do a very important project in cognitive linguistic field. It's called WordNet. That he looked at English vocabularies. And at that time, up till George Miller's work, the way we organize English vocabulary is what? How do we organize tens of thousands of words in English? Anyone? Is your microphone on? Is there anyone can guess how, it's on there. Yeah.
Ontology.
What kind of ontology? Okay, well, nice try. Before George Miller, the way we organize English words is through a dictionary by alphabetical ordering. So you have A, B, C, D, E, and just go under that. We still use it. Before internet, I learned English when I was 16. I remember I carry a big fat dictionary with me every day, and I flip through that through alphabetical order. But George Miller says humans don't organize semantics that way. Humans organize semantics in ontology, that's what you say. And that ontology has a structure. For example, for objects, we can organize it from very coarse category to very fine-grained category. For example, German Shepherd is a type of dog. So German Shepherd will live in a very low level, we call leaf level. Its immediate parent is dog. And dog is a kind of canine. Its immediate parent is canine. And of course, dog has a sibling. For example, I might be wrong, but maybe fox or something like that is a sister of dog. And a canine is, let's say, a type of, mammal. And one of the parents of canine is mammal. You just keep going up. And that's the ontology of WordNet. It was a very new way of organized semantics and words. And George Miller is a linguist, and Christiane Feldbaum, as a more junior researcher, was working with him for many years. She was the president of WordNet, and WordNet by 90s became one of the most important tools of natural language processing research. By the way, anybody in the audience who is from NLP, not computer vision? Okay, so we do have NLP researchers. So WordNet is a very important tool in NLP. But when Christiane and I met when I was interviewing at Princeton, she knows I do computer vision. And she asked me a question. She said, Fei Fei, when we manage WordNet and we use WordNet, I think it would be really fun to explain the meaning of a node. That's what they call synset. A dog is a synset, German Shepherd is a synset. With a picture next to the synset, because a picture can tell a lot. So if we put a picture of German Shepherd, it looks like it explains better than a dog with pointy ears and black back and brown colors and all that. You just show a picture of German Shepherd. And she said, we've been trying to get an undergrad to just attach a picture to WordNet and do that for all the 80,000 nouns in WordNet. And she even said that project is called ImageNet. But no students succeeded in that project because it's extremely boring. It basically means you have to find a picture and that explains that node, and that's it. And it's 80,000 nodes. So Christiane said, Fei Fei, we just gave up on that project. Can you use computer to automate so that we can have one picture per node? So I went back, and in a few months, I became a faculty at Princeton. And I thought about that project again. And I remember one day I was realizing that there's an entirely new opportunity. It's not about using one picture to explain every node of WordNet. It's about using WordNet as an ontological backbone to create a massive computer vision data set that can enable machine learning training in a way that machine learning community has never seen before. Because by then, machine learning is all about using a few pictures or a few data points to keep overfitting on our models. And then we do all kind of tricks, whether it's, you guys probably don't even know, like shrinkage or Bayesian priors. And there's just a lot of tricks. We try to overcome the problem of overfitting in the models, but the bottom problem is we don't have enough data. So I realized that the original ImageNet project Christiane was proposing has no hope, but we can completely flip this around, and it's not a language project, it's really a vision project, but using WordNet as the best backbone, because WordNet was about object categories. It's not about alphabetical lists of words. And that could be a new way of doing computer vision, and we can reboot machine learning, because machine learning was kind of stuck, whether you're in kernel method of SVM or Bayesian graphical models, it was just stuck. So I went to Christiane, I said, Christiane, do you mind I reboot the ImageNet project? But I'm gonna do it differently, because it's not about using one picture to explain the word, it's about thousands of pictures to jumpstart machine learning. And she said, of course, because nobody's working on it, it's yours, take it from there. And so that was the birth of ImageNet, was a serendipitous meeting between me and a cognitive linguist and their amazing work in WordNet that sparkled our idea that we have an ontological backbone to use for object recognition. So we started doing this. Our goal, of course, is not one image per node. We want to do thousands of images per node. And how do we do that? Well, we started, that was 2007, so the internet was bigger than 2000. So Google has happened. So we started downloading pictures from Google. There were some technical glitches, like Google actually limits how many things you can download. So we had to use dynamic IP and all that silly ideas. But the images we can download based on WordNet sunsets from Google, and you guys don't even know some search engine called Pig Search, from Netscape, not Netscape, Alta Vista, very old search engine, and later Flickr. But they're all very, very, very noisy. We eventually downloaded 1 billion pictures, but we have to clean it up per sunset. And then we were hiring undergrads from Princeton, $10 per hour, and asked them to click on the picture. Does it have a German Shepherd? Yes, pass, no, pass, yes, pass. And after like 3 months, we made no progress. My undergrads are just too slow. And my graduate student in charge of this project, Jia Den, was so desperate. He was like, I don't want to do this project anymore. And then we started thinking, why don't we use computers to automate? We have models that can recognize German Shepherd. But those models are not good. So if we use computers to automate, we are at the mercy of whatever performance computers were at. And then we will not have a ground truth data set. And that defies the whole purpose of training and benchmarking. So we were kind of stuck between humans are too, like undergrads at Princeton were too slow and machines are not good enough. And then again, one day in 2000, early 2007, I was talking to a master's student in the hallway, and he just came from Stanford. He did one master at Stanford, and he joined Princeton as a master's student. And he said, Fei Fei, I heard there is a thing called Amazon Mechanical Turk. And Silicon Valley, I know there is a startup that uses it to label some colors. I've never heard of Amazon Mechanical Turk. And that was just a weird name, actually. So I went to the internet and Googled, went to the Amazon Mechanical Turk site, and I learned it was an online market of global workers who are seeking online jobs, and then we can have global, people, agents putting out jobs. I still remember the moment I saw the Amazon Mechanical Turk online market, the moment I knew ImageNet will happen. Before that, I did not have the confidence ImageNet would happen. And we were just trying different things. And of course, we became early adapters of ImageNet. There was a lot of trials and error. When you are hiring 50,000 global workers from 167 countries, there are all kinds of issues. It was funny, at some point we even have to deal with tax paying for American workers. And it was just, we had to study tax laws and understand what we can do. So it took us to many different unexpected events, and lo and behold, 2.5 years later, in 2000, we put together the first iteration of ImageNet. I think it was 10 million images, and we wrote a CVPR paper to release this data set, and it barely made into the conference as a poster. And I remember I told my graduate student, even before we published this paper, I told my graduate student this would change the history of machine learning. Not because I was a prophecy or anything. It's because we knew that machine learning as a general concept is a very data-driven technology. And mathematically, we were stuck because of the lack of data as a field. And ImageNet really just provided a whole different way of looking at machine learning and looking. We didn't print the ImageNet challenge in. We knew ImageNet would change machine learning, not because we were just smart. It's everybody, that was the point. It's because we as machine learning researchers knew that mathematically the foundational mindset of machine learning was about training and generalization, and generalization relies on data and highly generalizable models that don't get stuck in overfitting all the time. So we wanted to use that kind of large data to really, and can you hear?
Yeah, it's cutting out. The internet is. Can you guys? Yeah, the internet is cutting out.
Okay. Can you hear now?
Yeah, now it's good.
Okay. Okay, now it's good.
Yeah.
Just wave at me if you cannot hear. Okay.
Good.
Okay. Anyway, I want to just fast forward. Okay, so we were excited by ImageNet. 2010, we made ImageNet challenge because we wanted to invite global research community to join us. And the first 2 years was just slow and trial. 2012, we rolled out ImageNet challenge, and about 15 days or 10 days before ICCV Florence, Italy, we got the results from Jeff Hinton's lab called Supervision. And that was AlexNet, the 7-layer convolutional neural network trained on 2 GPUs that beat previous results by a large margin in ImageNet challenge. And when we saw that result, we knew it was a historical moment. I remembered I was not planning to attend ICCV Italy because I had a very tiny baby at home. But I had to buy a last-minute airplane ticket in a middle seat and go to Italy to announce this result, and came back after 24 hours because we were so excited that we knew that the combination of convolutional neural network and ImageNet is changing the history of machine learning and computer vision. So that was the story of ImageNet. And I guess you know now it's useful quite widely for many things now.
Yeah, this is an experiential story. So I think, yeah, the image has revolutionized the computer vision field, and no doubt about that. So I'm moving to the next question. As I see, there is an architecture behind you or something, a work you are doing.
Okay.
So the question is, what do you think are the three most interesting research directions or open problems in computer vision?
Okay, good question. My most exciting area of research right now is the loop between perception and action. Because I think computer vision has been very passive in the past 2-3 decades. Image that is a very passive task. You look at a picture, you call it a cat or a dog or a flower. But evolutionarily, vision is active. In fact, there's biology studies to show it is because of vision animals become active. Movements start to happen, navigation, manipulation. So the loop between perception and action, I think it's fundamental to both to enable the right action as well as to improve perception. Humans constantly move and focus on different things to accomplish tasks. We don't just sit here and stare at pictures after pictures. So my lab, if you guys follow my lab's work or browse our work, you'll notice we are moving very, very heavily into robotics. So with both manipulation arms as well as navigation robots, is because I find active vision very, very exciting. So that's one area of vision that excites me. Another area of vision that excites me is actually about learning, is that everybody knows supervised learning in a classifier fashion is what ImageNet is about, but I think we have done a great job as a field in solving a lot of these fundamental problems. Right now, if you look at ResNet and all these variations of ResNet, it really is beating the tasks, and seeding the tasks. But human learning is much more flexible. It's, it has rewards, it has one-shot learning, it has unsupervised learning. So I find recent work in self-supervision as well as curiosity-driven learning, these two sub-areas, very fascinating. I don't think self-supervision will solve everything, but I think it's a wonderful way of jump-starting a lot of representation. And I think curiosity learning gets us closer to understand the difference and similarities with human learning. So I'm working with neuroscientists on curiosity-driven learning. So that's two areas. The third area, I'm debating. I have two equally important areas, but I'll choose one. The one I didn't choose, but I really find exciting, is also vision and language. But I'm not going to choose that one. I want to choose an application area that I've been very excited about, and it's healthcare. And if you look at my work in the lab for the past 8 years, up to 8 years ago, I was never in application area. I was always doing my CVPR papers, my NeurIPS papers, it's all basic science research. But 8 years ago, I had the opportunity to talk to a lot of doctors, and I found an incredible partner, collaborator, Professor Arnold Milstein at Stanford Medical School, who's really thinking deeply about how to improve clinicians' behavior to treat patients so that we don't have medical errors, we have better workflow, or how to help patients to be safer, how to help our aging seniors to not have accidents at home, to have early detection of dementia, and many of these problems. And these problems don't have a medical way of, it's very hard to diagnose. How do you diagnose a surgeon's mistake in the operating room? So it's a very similar problem as self-driving car, where you need sensors and computer vision algorithm to constantly understand the behaviors of many things, from people to devices to, and also understand the environment and create that real-time feedback. But instead of just focusing on self-driving car as the rest of Silicon Valley, healthcare saves lives. Healthcare is critical for global population, so I'm passionate about healthcare and using computer vision, smart sensors. We use a lot of Connect sensors, thermal sensors, connecting that with video analysis, human behavior understanding, pose recognition, object recognition, human-object interaction. Use these algorithms to help healthcare applications. So I'm very excited by that. So that's my 3 choices.
No, thank you. So that you mentioned the medical application. The question, is there any problem or an ethic dilemma in the computer vision field that has to be solved or addressed?
Wait, sorry, I didn't hear the question well. Can you repeat that, please?
Yeah, I said that you mentioned the application in medical field. Is there an ethics or ethic dilemma or problem that should be addressed or solved in the computer vision field?
Absolutely. Absolutely. In every single application, many of you know my work. I think ethics is a huge consideration in technology. This is not just about AI, right? The technology is a tool. A tool is a double-edged sword. Humanity has always faced this issue of ethics and value versus applications and technology advances. In medical situation, we have many aspects of ethical consideration. Many of you know the bias aspect. Your training and algorithm can have biased effect. Our research don't deal with face recognition biases because we use depth camera. We don't do face recognition. We have just, depth information. But doesn't mean we're not biased. If we train on particular, if we're not careful with the kind of training, we can still face training bias. Privacy is a huge issue, right? It's how do you respect privacy of patients, privacy of clinicians, privacy of visiting families in healthcare? It's good that this industry is highly sensitive to privacy. It's highly regulated because for many privacy reasons. So our doctor collaborators and nurses are very sensitive to privacy. So it puts vision researchers on a very high standard. So I really like that. But there are other more difficult ethical issues. I remember, this is not my research, but a colleague of mine at Stanford is doing palliative care. Do you know the word palliative care? Is for very, very sick seniors who might be at the end of their life. And it's important medically to help them and also emotionally to help them. But what if you have a machine learning algorithm that can tell your probability of dying, say tomorrow? Do you want to know? Should you know? Do you tell the patient? Do you treat him or her differently? Do you inform the family? These are issues that we've never faced before because nobody had that predictive capability. But now machine learning might. I'm not saying it's perfect, but it might, right? Because through big data and many training, we might be able to have a better way of telling or recognizing the end of life moment. But what is the ethical implication? That's not my work, but it's the work of my colleagues at Stanford who are thinking deeply about this. So in short, absolutely, this is why I advocate for new generation of technologists like you that human values are important in our work, and ethical considerations are important in our work. It's not that we just do our algorithm and then let the ethicists figure it out. As technologists, we have to be aware of this from the get-go of the design and work with the ethicists, the users, the consumers of our technology to understand the design choices.
Yeah. Thank you. So, moving to another question, is what advice would you give to young researchers, especially in Africa, in computer vision?
It's a very exciting field. If you chose computer vision because of your passion, congratulations. I think as a professor for almost 2 decades, it makes me the happiest when I work with young people who have true passion in a particular science. I also tell young people that don't choose any you a lot of money. Working in a field you love is the biggest reward. So find your passion is my first advice. And if you're already passionate about computer vision and really want to make a difference in your study, I highly advocate interdisciplinary research. And interdisciplinary research is easier said than done. Because what is interdisciplinary? Do you just take algorithm A from natural language processing and stick it to problem B in computer vision, and is that interdisciplinary? I think that is, but it's possibly just a fairly shallow way to do interdisciplinary research. I think that I encourage my students to read outside of, in addition to the CVPR, ICCVs, read the NeurIPS, the ICML, read the Eichler papers, but also read neuroscience, read psychology, read philosophy. If you're interested in social issues, read about fairness from ethics community, read about work, future of work. So I think there's a lot more opportunity in computer vision in the coming years in more interdisciplinary areas than just basic science computer vision. So I highly encourage students to pay attention and see how you can think out of the box. I mean, as scientists, that makes us innovative and creative. That's the second advice. One last advice, I think, is that this is less about doing computer vision. I think just young people in your career, being knowledgeable, being competent is. There's also one thing I tell my students: having grit is really important. And I don't know if you know this word, GRIT, which is perseverance. And PhD study is hard, AI is hard, and be persistent and do not shy away from challenges, and develop that capability to rise up to the challenge is invaluable to your research as well as to your life in general, even whether it's computer vision research or not. So I encourage my own students to be aware that this is an important personal character to cultivate.
Yeah. So as we know that computer vision requires millions of images and GPUs, sure. So do you have any advice for resource-constrained students, especially here in Africa? And how could we still participate at severe prior with these resources that we have?
So sorry, are you talking about the data constraint or compute constraint? I didn't hear well.
Yeah. The hardware constraint, the resources constraints.
Yes. So first of all, I recognize that problem, and I really admire that students from Africa, that you guys probably even have a more difficult challenge than we do. In America, for example, Stanford cannot compete with Google and Facebook and Microsoft or DeepMind on compute ourselves. We constantly suffer from that problem. But I believe the following: every challenge is every crisis is an opportunity. The fact that we, either in America, in academia, or in Africa, we don't have enough GPUs to burn for every paper means we can be more creative. I really tell my students before they choose a project, and this is really true, that I will ask my student, every time they pick a project, I will ask them, can the Googles and Facebook and Microsofts of the world do your project easily? Meaning, if they have 200, they're gonna be better. Can you hear me?
Very good.
Yeah? Can you hear me now?
Yeah, we hear you. Yeah, we're good.
Yeah. So I'll repeat a little bit. Lack of data and lack of hardware is an opportunity for more innovation and creativity. Every time my students pick a project, before we start doing it, I will ask my students, can the Googles and Facebook and Microsoft of the world do it with 200 GPUs or more GPUs and more data? Can they do it better? If their answer is yes, we don't do it. Because that means we're not the right group to do this, and I challenge my students to be more innovative and creative, to work on problems that even 5,000 GPUs might not solve, or work on problems that's not about data and the size of training data. So there are many, many problems. Our brain works on 20 watts, our brain. That's much less energy than the light bulb we use in a room. And yet we have incredible intelligence.
Yeah, this is a precious advice for to be innovative here, especially in Africa. So, in relationship with other subfields, what is the future of combining computer vision with other senses like text and audio?
I think there's a bright future. I think multi-dimensional, multi-sensory integration is going to be more and more prominent, especially again in robotics setting. I think we're already seeing that happening. I'm extremely excited by vision and haptics, vision and audio and all that. So.
Yeah. So we are going to ask more personal questions. What is it like to be being a woman in Silicon Valley, and what are your role models, if you may?
Great question. I don't think it's easy. If I say it's easy, that means I'm in denial. I think as a woman in tech, we face a lot of challenges. We don't have enough peers. We don't have enough mentors. When competition comes, women tend to be overlooked. We have to try a lot more to prove ourselves. Even in my senior position, I still feel that glass ceiling hitting. But in the meantime, it's changing a lot. I've got great support. I've got colleagues who are supportive of me. I see more and more my students are different, whether it's men or women. So I see the culture changing, and many of you know I'm I co-founded and I'm the chairperson of AI for All, and it's a nonprofit organization that encourages students of diverse background to participate. We haven't gone international yet, but my dream would be one day AI for All will come to Africa and work with African high school students. That's the population we're working. But in America, we're in 11 universities, facing the local high school community and encouraging women, racial minority, rural population, low-income family students to join AI technology, because their values, their talents, their voices, and their needs are super important. So from this point of view, Africa is a huge part of our world, and it's also a continent in so much transformation and so important to all of us that I encourage that. My role models, oh boy, that's a tough question. I'll tell you one role model that you might be surprised to hear. One of my favorite scientists of all time is Albert Einstein. First of all, I was a physics student, so I love physicists. But what I love about Albert Einstein is, first of all, he's just, you all know how unbelievable he is as a scientist, his ingenious, his creativity. But what I also love about Albert Einstein is he's a humanist as much as he's a scientist. If you look at a lot of his writings, his essays, his letters to other scientists, especially towards the more senior year of his life, he's deeply compassionate about human suffering. He's worried about social issues. He's an accomplished musician himself. He writes well. He's just a person with concerns about humanity. And as a scientist, I aspire to be both a scientist and a humanist, because I think that makes me a better scientist, and more importantly, it makes me a better human.
So a last question is about robustness in computer vision. How is computer vision algorithms and models are robust against adversarial attacks?
Oh yeah, that is a fascinating field of research. I'm clearly not robust enough right now. So this is an area of research I don't do much, but I do look at the papers and follow the latest research, and I'm just so in favor of this line of research. I think it exposes a lot of limits of the neural network representation, and I think this is one area of research that's quite exciting, from both security point of view as well as from theoretical machine learning point of view. So if any of you is interested in this area of research, I think it's a fascinating area, and it has a lot of room for good research.
Thank you, Fei Fei, for your time. Now it's your turn if you have any question for us.
Yeah, first of all, well, too bad I'm not with you guys. Otherwise, I would love to know you more. But well, tell me. Well, first of all, tell me how active is the community of computer vision in Africa? I don't have a good sense of, how many universities are you involved? Are we having a lot of graduate students? Are you lacking professors, or you have lots of professors? What's the...
I think...
I'm Tony. student JQuad. Tony, I'm student JQuad. First, one thing is most we are under pressure and we are discouraged from our peers as students. Then sometimes most of the time we require to do research on our own. So that's two of the things that I've noticed. That's all.
The connection is not that great, I have to say, so I didn't hear everything you said.
Oh, the first I said we face discouragement. So most of the times we had to isolate and do a small research online, and all the resources we go through, we had to configure which resources are good for us for our own through either friends who are in industry and other sectors, the economy. Yeah.
Who discouraged you?
A lot of forces we can't say for that, but mostly is from lecturers and fellow peers. Yeah.
Okay. We have hands up here in the front.
Come in.
Hi, I'm Anna from South Africa, and I don't think we really have a very large community, but there is definitely a lot of interest in computer vision. Myself, I'm from the University of Pretoria, and there we currently are starting a research group that is going to focus on computer vision applied to astronomy, because we are actually currently, there is this really huge radio astronomy SK array that's been built, and I think it's a really exciting application area. Because of that, astronomers are really trying to engage with computer scientists, and we're trying to kind of develop a community specifically around that application area, because people have access to unique data, and we really want to kind of make an impact as South Africans, I guess, as Africans. So that's kind of what I can say on the topic. There's definitely a lot of interest. A lot of students approach me telling that, it's so easy these days to read about CNS, to try it out for yourself, and once you see it in action, it's really easy to get excited and want to contribute to that field. So that's my experience. I'm currently supervising 2 students, master students. Of course, I'm myself not a very senior member of academia, but there is definitely a lot of interest, and I hope it's going to grow.
That's awesome. That's awesome. I think there are a lot of interdisciplinary data sets in Africa, from astronomy to industry to agriculture to environment. These are all really good opportunities.
Well, I think also in addition to that, just advancing the Indaba, I have seen that a lot of presenters from other African countries were actually specifically applying modern machinery technologies to the specific fields like agriculture, medicine, and stuff like that. But then they have plenty of application areas which I think very unique, and I believe that's where we can really contribute, solve problems that only we face.
Right. Cool. Yeah. Thank you.
I am Bayo from Nigeria, and my take is first, we have our communities are growing nationally, so you have several communities here from Nigeria, different countries, all growing machine learning and AI competence alongside. Then I work in the industry, and I can tell you clearly that currently my organization is actually working with a PhD grad from South Africa on industry-related computer vision projects. So there's efforts in Africa, and like she said, there are several projects we've seen people trying to look at crops, malaria, and the likes of it, to apply this to our local problems. Thank you.
Thank you. Thank you.
Hi, my name is Musima. I'm from TUT in South Africa. I think some of the challenges that I picked up that we are having in our country, or maybe in Africa, is, especially from where I'm coming from, we still lack collaboration or networking locally, let's say the universities within South Africa, for example, because our target research is almost the same. If, for instance, one institution can collaborate with one company, then it becomes, we can share data set, for instance, for example. Another institution, when you go asking collaboration, then you find out, okay, this university is already engaged. Then it means the project now is only directed to one institution. So data set is still an issue. You find that you end up having an idea and then you get discouraged. So again, the resources, it's still a problem. We depend on, okay, we learn from some of the open sources, but we still lack to understand the security of, if for instance I'm still a learner, I find data set, if I can upload it on an open source, someone expert can use it before I can publish my work, for instance, even I'm an academic. So those are the kind of challenges we are facing.
Right. Do you guys know about the Kaggle website? Yep, okay, because that's another website with lots of data and also can do early tutorial of machine learning.
Fei Fei, do you know about Zindi? The Zindi website?
Cindy?
Zindi. So I have it for you after this call, because I'm be sure you have plenty of meetings for the rest of the day, is to check out the African version of Kaggle. It's called Zindi,
Okay.
Z-I-N-D-I, and they're one of the sponsors of Indaba. Actually, Kaggle is also one of our sponsors. But Zindi is our version, and our champion.
Okay, that's awesome.
And maybe you can
Yeah,
get the students
I have
to-
one last question. I have one last question before we go is, how can we help?
We have so many hands. We'll do one minute each, 1 minute each, 1 minute each.
Hello, my name is Raisije, and I'm a master's student. This year, actually, throughout my master's, I got an opportunity to collaborate with Tibnet, one of the students, and that was amazing. Yeah, it was actually amazing. If more of us can get more of those kinds of collaborations, I think that would actually help really, too much in terms of the quality of work, pushing it to more international standards. Yeah, because that's actually, I think that's what my friends and my fellow other colleagues actually need.
Hello, my name is Ope. I'm from Nigeria. One of the challenges we face in Africa and Nigeria generally, for me, is we lack research-focused communities. And I think one way we can help Africa, because we are really hungry in these technologies, but we don't have that much capacity. We haven't built our skills capacity to that level, probably because we lack academic research lecturers or research departments in that area. So one very good way you can help is to beam that light on Nigeria and Africa on research-led communities, create more research-led communities for us so that we can get into these places and do more lab work and just focus and do research, and then we can apply it to our own local problems. Yeah, thank you.
For my case is volunteerism, whereby, like you said, you have a startup, you can call up for volunteers, thereby be mentoring, and also via the mentorship. Here in Kenya, we have some communities we are doing research, so also you can assist us in some funding. In that case, that's all. Thanks.
Sorry, I didn't fully understand. Can you come to the front? Because I noticed the more front it is, So you're talking about startup community. I didn't fully understand the proposal. What we can
for
do.
my case, it's of volunteerism. Whereby you can call upon volunteers who are ready to do research, because if you volunteer, you learn a lot, and that's more engaging, and also you help us mentor what's our strength and also our weaknesses. Yeah.
Okay, so it's still similar to the first suggestion. Is more collaborative and mentoring opportunity, right?
I think that summarizes it, unless someone asks another question. Maybe if one of the students can take up one of the challenges on Zindi and check out an African data set. There are plenty on the African camera as well.
Definitely, and I have taken down notes about ways to help, and as I meet with my fellow academian leaders as well as industry colleagues, both within America as well as I do have opportunities to meet with global leaders and sometimes leaders from Africa, I think there are concrete, hopefully I can suggest some concrete ways, for example, to create more collaboration channels, mentorship opportunities, to encourage academic leaders in African universities to create, more modern degrees and departments related to AI, machine learning, computer vision, research, and these are the things that I have taken down notes, and hopefully we'll have opportunity to just encourage these things to happen.
Thank you so much for your time, for your support, for video linking with us from California, for training amazing graduate students like Timnit who are champions for us all over the world. We really, really appreciate it. Thank you for all your research, for the resources in data sets that we created. I think on behalf of the African machine learning community, shall we just give Fei Fei a big round of applause?
Thank you. And I hope to come visit you guys in person one day.
We would be very happy to host you. Yes, some of us are inviting you to Indaba, but we won't invite you on stage. We'll do it properly through a formal letter. Thank you so much for your time. We really, really appreciate it.
Thank you.
Thank you.
Bye.